Hello everyone, welcome back to the channel. This video will be just about proving identities. Yes, these are grade 11 identities. If you're doing grade 12, please do not skip the video. It's very important that you know these things, because the same rules apply, the same logic applies. The only difference is that in grade 12 you are doing double angles, but if you don't have the concept, the grade 11 concept, you'll have problems when you go forward. Okay, whenever I prove identities, I did highlight on lesson number 27 and 8, no, 28 and 9. Yeah, lesson number 28 and 9. That's there are only 3 steps in trigonometry, whether you are simplifying, proving identities, and maybe finding the general solution. The first one, whenever we prove, the first step will simply say step number 1, you must reduce all your angles. You must reduce all angles by using the reduction formulas. Then these are the steps. Step number 2, you must check if there are two things you can change into one thing. Basically, this thing directs you straight to the square identities. Are we together? And then the last step simply says change everything into one trig ratio. And if you can't do that, just change everything into sine and cos. Are we together? Whenever you change everything into sine and cos, you will either use the square identities or the quotient identity. Are we together? Just a quick reminder, guys, of the square identities. Square identity. The first one is the one that says sine squared theta plus cos squared theta is 1. Secondly, sine squared theta is equal to 1 minus cos squared theta, which can be further factorized because it's the difference of two squares. And then thirdly, we have cos squared theta is equal to 1 minus sine squared theta, which can be further factorized because the difference of two squares. Okay, guys, please go and check lesson 28 and 29. That lesson is very those two lessons are very important, especially for grade 11s. They are very, very important. And then the only quotient identity we'll need to prove these things, the only one is the one that says the tan of angle theta is cos theta is sin theta all over cos theta. Okay, now let's prove the identity. First question, let me use black. I must show that 1 plus sine theta all over cos theta is equal to cos theta and 1 minus sine theta. Are you together? In this case, it doesn't matter. I can either simplify either the left hand side or the right hand side. Né? Whenever I prove identities, guys, we always choose the most difficult side and simplify it. So in this case, it doesn't matter. I'll go with the left hand side. I have 1 plus sine theta all over cos theta. There's nothing else I can do with this thing, guys. Né? However, please note that in maths, whenever I multiply anything by 1, I'm not changing. I'm not changing anything. Are you together? Anything multiplied by 1 is simply that thing. Are you together? So I can just multiply by cos theta over cos theta, which is 1. This thing simply means that at the top I will have cos theta 1 plus sine theta all over cos squared theta. There's nothing I've changed so far, but I can apply my square identities. Right? I know that cos squared theta can be written as 1 minus sine squared theta. Then I have cos theta just want to write in different color to show that I've changed something. Okay, this thing can be further factorized as 1 minus sine theta 1 plus sine theta, because it's the difference of two squares, right? So this will go with this one, and I'll be left with cos of theta all over 1 minus the sine of angle theta. This is how you prove, this is how I've proven the identity. Né? Firstly, the angles were already reduced, so I didn't have to reduce the angles. Then I went to step number 2. Step number 2, it says check if there are two things you can change into one. There are no square identities there. Then step number 3, everything was already in sine and cos, so I just worked with sine and cos right together. The trick here was to just multiply the top and bottom by the same thing, and then just keep on working. Okay, then let's do the second one. We are supposed to show that sine squared a plus cos a minus tan a, then we have cos a plus tan a is equal to 1 minus tan a squared minus tan squared a. So here I'll just need to simplify my left hand side. Okay, already I have a sine squared there, a sine squared a plus inside the bracket I can see this is a factorized version of the difference of two squares, because the first terms are the same, the second terms are also the same, and then the signs differ. So this thing just implies that I have I had a difference of two squares rather, which was factorized. So I can simply say I have cos squared, how, just like that. Okay, I have cos squared a minus I. Guys, why is it this simple? Okay, I've removed the brackets. Okay, and then I know that sine squared plus cos squared is 1. Then the left hand side is equal to the right hand side. This is so simple. Why can't you? 1 minus tan squared a. So now I've shown that the left hand side is equal to the right hand side. Okay, and then now maybe this one will be a bit interesting. I have 1 over cos of theta minus the cos of theta multiplied by tan squared of theta all over 1 is equal to cos theta. I'll simplify the left hand side. I have 1 over the cos of theta minus this thing is divided by 1, so I don't need to divide this thing. So I'll simply write cos of theta, and then I have sine squared theta over cos squared theta, right? Because I'm changing everything in terms of sine and cos. This is 1 over cos theta minus, please note that this guy will cancel with one of these. Then there at the top I'll have sine squared theta all over cos theta. Now I'm adding fractions, at least this one. Now I'm adding fractions. My LCD is cos theta. Okay, since I have the same LCD, all I need to do is to just subtract these two. But I know that 1 minus cos squared theta is equal to 1 minus sine squared theta rather is equal to cos squared theta. So I know that this will cancel one of these. I'll be left with cos of theta. Okay. By proving this thing, guys, now the first thing I did was to just because the angles, like whenever I prove identities, now step number 1 wouldn't be that necessary, because most of the times angles will be reduced together. You'll just focus on step 3 and 2. Step 2 must check whether there are two things you need to change into one. Here there were no square identities, so I literally skipped that step, and then I went for the third step, whereby I've changed everything into sine and cos. I've changed my tan squared theta into sine squared theta over cos squared theta, and then they cancelled. I was left with 1 over cos minus sine squared theta over cos. Then I subtracted the fractions, and then and then I found the solution. D, we are told that 2 sine theta multiplied by cos theta all over sine theta plus cos theta is equal to sine theta plus cos theta minus okay. The most complicated side this time around is the right hand side. Whenever I take the right hand side, the first thing I need to do, okay, let me write the right hand side. The right hand side is equal to cos sine theta plus cos theta all over sine theta plus cos theta. Alright, together. The LCD in this case is sine theta plus cos theta. Then whenever I multiply each term by the LCD, I'll simply get each term by the LCD. I'll start by multiplying sine theta by the LCD. I'll get sine theta, then the sine theta plus cos theta plus cos theta, and then there is sine theta plus cos theta, then I'll have the minus 1 there all together, and then this will give me sine squared theta plus sine theta cos theta plus sine theta cos theta plus cos squared theta minus 1. Please note that, guys, for me to get sine squared theta, I multiplied this and this. For me to get this one, I said sine theta multiplied by cos theta. For me to get this one, I multiplied these two. For me to get that one, I multiplied cos theta and cos theta. This entire thing is divided by sine. Okay, now I know that I have sine squared theta plus cos squared theta, sine squared theta plus cos squared theta, which is equal to 1, right? And then I have sine theta cos theta plus sine theta cos theta. That will give me 2 sine theta cos theta. Then I still have my negative 1 there on the side, divided by sine theta plus cos theta. These two things will subtract one another, and then I will be left with 2 sine theta cos theta all over sine theta plus cos theta. All together. Now I've proven that the left hand side is the same as the right hand side. And then I'm supposed to show that let me use different ink. Cos beta all over sine tan beta multiplied by cos beta is equal to 1. Okay, I'll first simplify the left hand side. On the left hand side, I have cos beta all over sine beta, right? Plus, I can change this thing into, I must change everything into sine and cos, right? Sine beta can be written as sine beta over cos beta. This entire thing is multiplied by cos beta. Okay, according to the Bodmer's rules, I need to simplify everything inside the bracket first. Okay, that means I'll have sine beta multiplied by cos beta. And then when I multiply both terms inside the bracket by the LCD, I'll be left with cos squared beta plus sine squared beta. And then I know that sine squared beta plus cos squared beta is equal to 1. This thing is divided by sine beta multiplied by cos beta, all multiplied by cos of beta. Now this will cancel with this. I will be left with 1 over sine beta. Therefore, I've proven that the left hand side is equal to the right hand side. Does it make sense? Okay. F, I'm supposed to show that 1 over 1 plus sine theta plus 1 over minus 1 minus sine theta is equal to 2 tan theta all over sine theta cos theta, right? Then all I need to do here is to just simplify the left hand side first and check whether it will be equal to the right hand side. Whenever I simplify my left hand side, I will have an LCD. The lowest common denominator is 1 plus sine theta all over 1 minus sine theta. Now together. If I multiply the first term by the LCD, the 1 plus sine theta will subtract one another and I will be left with 1 minus sine theta. Plus, take the LCD, multiply the second term. The 1 minus sine theta will cancel one another. I'll be left with 1 plus sine theta. So this thing here is equal to the negative sine theta and positive sine theta will subtract one another. And then 1 plus 1 will add one another. We'll have a 2 at the top. There at the bottom I have a factorized version of the difference of two squares. That means I'll have 1 minus 1 minus sine squared theta, which is the same as 2 all over cos squared theta. Together. This is the left hand side, right? We can see that this thing is not equal to the right hand side. Okay, let me try and simplify the right hand side and see that I wouldn't get the same answer I did there. Okay, so now the right hand side is equal to 2 times tan theta all over sine theta multiplied by cos theta, right? I must just change everything into sine and cos. I will simply have 2 sine theta over cos theta. This thing is all divided by sine theta cos theta. Whenever I'm dealing with fractions, guys, I don't want to have a fraction within a fraction. I want to have whole numbers divided by whole numbers. So I'll simply divide by both the top and bottom by the LCD. Whenever I do that, I'll be left with 2 sine theta, because this will cancel this, all over sine theta. Cos theta times cos theta will give us cos squared theta, right? But please note, guys, that this guy and this guy will cancel one another. We'll be left with 2 all over cos squared theta. So my right hand side, whenever it's simplified, is equal to 2 over cos squared theta. Also my left hand side, whenever it's simplified, is also equal to 2 over cos squared theta. So I can therefore conclude that the left hand side is equal to the right hand side, which is equal to 2 over cos squared theta. And then I'm given 1 plus tan squared A multiplied by cos A all over 1 minus tan A is equal to 1 over cos A minus sin A. Okay, could have used, but it's fine. The left hand side, ne? Whenever I simplify the left hand side, I'll always start with my bracket first. I'll have sine squared theta multiplied by cos theta all over 1 minus okay. Before I even move forward, guys, let me start by simplifying whatever that is inside the bracket according to the BODMAS rules, right? Inside the bracket I have my LCD there, which is cos squared A. Whenever I multiply A by the LCD, I'll get cos squared A. Whenever I multiply the second term by the LCD, I will be left with sine squared A. This entire thing is still multiplied by cos A all over 1 minus sine A over cos A, right? But cos squared A and sine squared A will give me 1. Then I'll have cos squared A multiplied by cos A all over 1 minus sine A over cos A. But please note that, guys, this will go with one of these. So at the top I'll be left with 1 over the cos of A. The bottom is 1 minus sine A over cos A. Now whenever I deal with fractions, I don't want to have a fraction within a fraction. I want to have whole numbers divided by whole numbers. So I'll multiply the top and bottom by the LCD, which is equal to what? To cos A. Okay, whenever I multiply 1 over cos A plus with cos A, I'll simply get 1. Then whenever I multiply 1 with cos A, I'll get cos A. Whenever I multiply sine over cos with cos, I'll get sine. So now the left hand side is the same as the right hand side. This is how you prove identities, guys. This was just covering the grade 11 part. Let me see whether there are other questions here. If there are no other questions, we'll just call it a wrap. It's a wrap. If there are no other questions, guys, now it's a wrap. Let me see. Can't even find one extra question. Can't believe this. Determine the general soul. I'm looking for a question, you guys. Please don't peel the moya. Bear with me. You. Now there are no other questions, guys. It's fine. Okay. So that means this is a wrap. Guys, thank you for being with me. I really hope this helped you a lot. Thank you for everything, guys. Thank you for your time. Thank you for giving me a chance to infiltrate your mind with mathematics. I hope I am not confusing you further, but clarifying some of the things maybe you misunderstood. Thank you for everything, guys. God bless you.